Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Today, we welcome Luc-Yves Pagal Vinette, Product Marketing Director for 5G Service Orchestration, Network Slicing, and Service Assurance at Amdocs. You know, the satellite industry has gone through tremendous innovation over the last few years with the emergence of software-defined payloads and LEO and MEO constellations. These new satellite architectures bring much more capacity and the ability to reconfigure and adjust payloads to changing missions on demand. These dynamic capabilities in space are driving the ground segment to keep up. Ground segment providers are embracing approaches proven in telecom and IT to overcome the scale and automation challenges being faced in the satellite industry. All of this has led to discussions on how virtualization, software-defined networking, and orchestration can enable ground networks to become much more agile to meet the new capabilities in space. To shed some light on these IT telecom concepts and how they can be applied to the satellite industry, we have with us, as we mentioned earlier, Luc-Yves Pagal Vinette, an expert in networking concepts such as software-defined networks, SDN, network function virtualization, NFV, the edge, and disaggregated networks. He is also, in addition to all that, he is also the Product Marketing Director for 5G Service Orchestration, Network Slicing, and Service Assurance at Amdocs. How are you?
I'm very good, thank you.
So, Luc-Yves, do you see any parallels with what the satellite industry faces today with what the telecom industry addressed in the past in terms of scaling and automating networks?
Yes, certainly. What we see in the satellite industry at the moment is really similar to what different telecom verticals have been facing, basically on the mobile sector, cable, fixed access. We've seen the same kind of strong dependence on hardware and hardware infrastructure that were supporting the value-added services. So the goal of these verticals were to find a way to replace hardware attached services to something that would be much more software oriented services. So the same conundrum that the satellite industry is facing.
In the world of computing here in the United States, what we've seen is 15 years ago, a transition from virtualization, virtual servers first came in, and then over the years, slowly they introduced concepts like software-defined networks. And maybe that is a model or a way that the satellite industry can look at them making these changes. So does this telecom experience offer a roadmap ahead for the satellite industry?
Yes, absolutely. There's a transition towards cloud native, possibilities. So when we say cloud native, it sounds like it is about containers and Kubernetes and that sort of these kind of tools and capabilities. Not only that, if you consider cloud native, it's an evolution from the physical network functions that we call hardware, and evolving gradually towards VNF, so virtual network functions. Then in that case, this is where virtualization is used in order to provide a sense of hardware being at the disposal of the software. Now, cloud native is getting a little bit further than that. So there's no intermediate layer between the hardware and the virtualized functions. So now everything is directly onboarded upon the hardware. So the goal of cloud native is to make things extremely flexible, light, and extremely responsive compared to VNF or even PNF. So the roadmap that you mentioned is absolutely related to cloud native in the sense of CNCF. CNCF is an organization that is part of Linux Foundation that is pushing the view of CNF being part of an ecosystem of tools. So these tools will allow basically to have configuration management, such as Ansible. You will have Kubernetes. You will have also a dashboard and graphical representation of the data. And you will have also monitoring with things like Prometheus. So the view of cloud native will push the bucket a little bit further to make this total appropriation of the software on top of hardware.
I think what you mentioned is a very good concept for our listeners to understand, is that this virtualization of the network will allow it to run on standard computers, and also it'll give it this concept of observability. I think that's one of the strengths of it, isn't it?
Absolutely. The key thing about all these elements, if you look at the different verticals that exist in telecommunication space, is that there's a different kind of silos that are treated separately, but nonetheless, the typical way to look at them across the board is really observability, and the goal of cloud native is to make these observability capable tools that will be used across the board. So there will be no boundaries anymore. So meaning that the cloud native will break up the boundaries between verticals.
Now, an outside observer could look at the satellite industry and say, well, why do you think it's taken so long for the satellite industry to embrace concepts such as virtualization and software-defined networks?
Well, first of all, there's something to take in consideration, that satellite service infrastructure in place rely heavily on hardware capabilities, such as the satellite dishes. You have the modem equipped with carrier Ethernet and also IP capabilities. The PEP, concept as well, that is really meant to accelerate TCP performance, monitoring, QoS, and even network management. So all these elements combined make, the satellite environment or vertical to be evolving slowly. But at the same time, there's a certain need when you want to take advantage of new capabilities such as MEO and LEO. You see the need to have a larger scale, but also to have a certain way to collaborate more easily with other verticals. So obviously, what you looking at when you consider satellite it's an opportunity. It's an opportunity for other verticals to leverage what others can't do. Basically, you have an urban kind of oriented consideration for other verticals, typically 5G. That in that case, if you think about rural areas, then in that case it would be extremely difficult to leverage 5G over these places. So this is where satellite infrastructure comes in, when it could bring something that other technologies can't.
About 10 years ago, I had a radio show, and I had an enterprise architect come in, and he walked into the room. He had like an 11 by 17 laminated piece of paper with teeny tiny type on it and millions of boxes of hits going there and that going there and everything else. So I got to ask about this architecture question, So how do you believe the satellite ground network needs to be designed in order to take full advantage of today's software-defined payloads and LEO MEO constellations? And this is a dynamic situation, so you can't take that laminated piece of paper. You got to throw it out the window. It's just changing every day, isn't it?
Absolutely. Well, the satellite teleports are really based on terrestrial networks capabilities. When you're looking at MPLS VPN, underlay routing, but at the satellite level, you see that LEO and MEO bring something a little bit different, in a sense where it will bring, Constellation or Hive methodologies. So if you look at that thing, then in that case, you need new approach about, network architecture and the service that will be running on top of them. Typically, this is where we see the value of overlay routing. So things like SD-WAN or SRVPN will bring something different, in a sense where, the payload will be distributed across the entire constellation in order to keep up with the flexibility that LEO and MEO provide.
I have more question about this dynamic capability. It's really kind of interesting. Now, with these software-defined payloads that can be reconfigured in minutes to meet changing demand and supply, so how can the ground system be automated to keep up with that rapid change?
Well, that's a very good question, because the way that it could be structured is really to take advantage of things like software-defined networking. This is a difficult notion, especially right now, because SDN tends to be dying at the moment. So SDN was a concept that was mostly driven upon silos. Basically, you will have an SDN capability to configure dynamically to onboard device and reconfigure, service on the based on dynamic, ways, and also to take in consideration the changing element that will make the requirement for changes. So SDN was mostly something on the per silo consideration. But nowadays, there's a new concept that is evolving now that is called network automation that brings the question at the higher level, meaning that networks, if they are in fixed access, if they are in optical, if they are in IPVPN, or eventually in satellite ground networks, then in that case, it will be similarly, proposing a view that, what is happening on satellite would have an effect on the fixed access and vice versa. So in such a case, you need to align the way that the networks is considered on an end-to-end basis instead of looking at on the per silo consideration, which will make networks to be much more dynamic but also complex. So this is why there's an evolution that is needed in order to tap into cloud native, in order to leverage fundamentally all the requirements that are needed in order to implement network automation. Because without cloud native, you don't have the flexibility and the scale that you need in order to adapt the network on changing conditions.
When you were speaking, I wrote down the word silo, and in the Washington, D.C. area, there's a company here called Silo Smashers. So maybe that should be the logo or the motto for the network automation. They're silo smashers, aren't they?
Possibly, yes.
Yeah. Luc-Yves, you earlier mentioned the term cloud native. Let's go back to that. So let's build on this concept of virtualization. So how can cloud native technologies help satellite network operators accelerate this transformation?
Yes, the concept of cloud native, it means that differently from virtualization means that you can basically take the hardware components and make them available leveraging what we call an intermediate layer that will be providing an abstraction view of these hardware components. Okay, so this will make virtualization a little bit heavy in a sense where you will have this intermediate layer and you will have the virtualized components. And to maintain this solution is kind of heavy on the CPU, on the memory, on the element to support virtualization. Now with cloud native, you go directly. You implement what we call containers or microservices directly on top of the hardware. You don't need to have an intermediate layer to be like this intermediate layer to translate hardware component into virtualized component. So now you have the cloud native notion directly on top of hardware component, which will make things extremely light, but also extremely responsive. For example, if you want to change the notion of a service when you have a VNF in virtualized component, then in that case, you will have to restart the VNF and in order to implement the change. With cloud native, it's totally different. You just push the command line, and after microseconds or milliseconds, you will have the change that will be implemented. As well, if you want to scale horizontally, meaning that you want to replicate the same service on the same device or different device, you can. You can also scale vertically, meaning that you can take more hardware resources in order to augment the capacity of a given service. So which means that with cloud native, you're changing fundamentally the dynamics of what we call services, what we call, service functions. They will become much more responsive, much more light. So if you want to take advantage of public cloud networks, in that case, you will be more capable of doing so by leveraging cloud natives.
Luc-Yves, I'm thinking about my software developer friends, and they use the term agile all the time. Well, this gives the tools to be agile, doesn't it? I mean, this is what it does.
Yes, absolutely. And this is perhaps I didn't use the adjective agile, but totally. And this is exactly what I was mentioning when I said about vertically, horizontally, you can scale the service on demand and on per request, or dynamically based on conditions that you will set when you will implement the service. So yes, totally. The agility is actually something extremely important in the view of cloud native.
The Constellations podcast was launched back in 2017. It was a small step for man, but a giant leap for podcasting. For the first time, you got to listen to leaders who focused on innovations in satellite and space networks. Today, thousands of people from all over the world listen to the Constellations podcast. Thanks to you, we've grown into more than just a podcast. Sign up for the Constellations newsletter to receive articles on current industry issues, podcast summaries, and contributed blog posts at constellationspodcast.com. Luc-Yves, the modern telecommunications industry has embraced massive scale in computing from cloud and data center providers, enabling telcos and mobile network operators to expand their customer reach, their commercial footprint, and accelerate their monetization perspectives. Can we expect the same for satellite network operators?
Yes, the difficulty for any service provider, even though it's using mobile as an MNO, mobile network operators, or communication service providers, or network service providers, or satellite network operators, they have the same difficulty to have an extended reach. So they want to improve the reach to tap into different customer bases. So in such a case, they need POP, points of presences. The problem is, if you want to have POP, it takes some location, some investment in real estate, and it's not easy to do so. It takes massive investment. So this is why, all operators at the moment, they invest, and also they collaborate heavily with what we call cloud, public cloud providers, basically hyperscalers. And it wouldn't be surprising to me to see in the near future satellite network operators to have the same collaboration that we see with the major tier 1, tier 2 service providers or mobile network operators to embrace the view of leveraging edge and MEC solution from hyperscalers in order to extend the reach. But also the same goes for enterprise. If you look at enterprise, the main difference between an enterprise and a service provider is that enterprise, they use technology, they don't resell them. Operators, they do digest technologies and to recycle them and to make a profit out of them. So and enterprise, they will do the same. They will extend the operational boundaries, the operational footprint with hyperscalers. On the other side, an operator will extend its business footprint with an hyperscaler. So satellite network operators will do naturally the same.
I was thinking about your introduction, and part of your title is 5G Service Orchestration. Then finally dawned on me, all these capabilities you just enumerated, that's the orchestration part. You're combining all these different aspects of virtualization and combining them to reduce cost, but giving each customer almost a customized menu for what they want. That's the orchestration part here, isn't it?
Absolutely. This is a natural evolution of the service infrastructure. The first notion of monetization comes with the possibility of service orchestration. But service orchestration comes with a certain vision and a certain cost as well, because yes, you want to be much more efficient on your operational. On the cost of operations, but as well it takes some investment because. Service orchestration means that you have different domain, intra-domain for an operator. You have, for example, if you take the example of an MNO, they have a RAN, they have a transport, and they have the 5G core. And that will be fundamentally the same for satellite network operators. They will have different domains. They will have to organize and make possible to orchestrate. Now, the difficulty is, do you need cloud native fundamentally across the board in order to have orchestration and automation? Not necessarily. There's a notion that is quite important, is the notion of hybrid networks. Networks will become much more hybrid than what we can imagine today. It means that you will have different possibilities within the service composition that will be under the underlying structure of any operator. You will have physical network functions. You will have virtual network functions with virtualization, but also cloud native functions. So meaning that across the board, you will have the same methodologies, the same ways to monitor them, to observe them. And on top of it, you will have service orchestration across the board, regardless of the different nature of these different components making the service composition.
You know, Luke, we are recording this in the Washington, D.C. area, and the tech community here is really, really talking about edge computing. In fact, there's a podcast called Feds at the Edge. So edge computing is really big. I think it's true all over the world here. So how big a role do you think edge computing will play in terms of supporting the increasing data processing needs of LEO and MEO satellites?
Oh, that's a fascinating question. Yes. This edge is actually an extended portion of the service infrastructure of any operators. So there's a natural incline to leverage edge as a means to provide a better service experience. And service experience means that you need to keep in mind or to keep up with the capabilities that will be coming from LEO and MEO. LEO and MEO will provide a much stronger level of throughput, tighter time delays. So they will be providing a different means in terms of service capabilities. And as I was saying before, the notion of point of presence will become extremely important for satellite network operators in order to be closer to the end user that will be obviously taking advantage of satellite with the principle of having a solid ground networks that will be supporting the satellite infrastructure. So this is why edge is so important, because at the same time you want to provide similar services or similar concept that you enjoy from MNOs or communication service providers. It means as well that you need to improve the quality of experience. It means as well that you will need to provide more enriched services. So edge will be also bring the capability of bringing, service functions or certain level of applications closer to the end user in order to improve his quality of experience, and also the fluidity of the service that they will be receiving from the operator.
Luc-Yves, when you use the word hybrid and edge, the next word I think is integration. So there's been a lot of discussion about the need for more seamless integration between satellite and telecom networks. So what role can carrier Ethernet play in making this possible?
That's a very interesting question, because carrier Ethernet already plays a role in different aspects of the industry today. Carrier Ethernet has been one of the fundamental, technology for communication service providers, also for mobile operations in order to support the ground mobile infrastructure. So what I see with carrier Ethernet is not only the possibility of connectivity with some level of flexibility, but as well, connectivity management, fault management, and service management with some performance monitoring for services. So carrier Ethernet will play a significant role to connect the dots between what satellite network operators will provide in terms of robustness in the services, but also flexibility. Not only flexibility in the way that the service will be composed, but also about QoS, because more and more differentiated services leveraging different class of services will be fundamentally important. So and carrier Ethernet has been profoundly changed over the course of time, thanks to the Metro Ethernet Forum that has been doing a lot of work around carrier Ethernet in order to make it available for cable, for mobile, for fiber access, but also for optical. So we see that really Carrier Ethernet is an ubiquitous technology that can be leveraged in different places, and fundamentally an element that will be, facilitating the exchange between satellite network operators and other, kind of operators in the industry.
Luc-Yves, I was doing research for this interview this morning, and I stumbled on this phrase, inter-domain orchestration. And it's not a bad characteristic of everything you just talked about, carrier Ethernet and edge computing and hybrid computing. It's just, it comes under this huge, complex domain orchestration, doesn't it? I mean, so many domains we're talking about.
Yes. So this is why now, the notion of, I'm sure you heard of that. It's end-to-end service orchestration or cross-domain service orchestration. It's fundamentally, changing the way that we understand, service composition or service instantiation. It means that until very recent past, and still valid today, you can still see silos of management. So you see that some operators still have difficulties to manage everything across the board. So this is why you need, different aspects of elements that will be supporting or allowing the end-to-end service instantiation to take place. Typically, inventory, to have a federated inventory, to have a service catalog that will be uniquely defined across the board, as well as the possibility of monitoring and observability across the board. So at the same time, you need end-to-end service orchestration, you need end-to-end service assurance. And as well, you need also to leverage new methodologies based upon AI, ML, in order to have data analytics functions. So you see, cloud native means a lot of more other things. Involved also more complexity, but the reward is exceptional. You can easily imagine the flexibility that network operators, regardless of the distinctions, if they are satellite or mobile or network, the kind of collaboration that they can embrace all together, leveraging hyperscalers or leveraging collaboration, direct collaboration, then it will imply naturally to have orchestration across the board, but also to have service assurance and also to have data analytics functions.
A lot of the terms you've used in the last 30 minutes are very technical and kind of appropriate for what's going on. There's a phrase in your world that I find kind of confusing. The phrase is network slicing. So can this function be extended to satellite service infrastructure? It's kind of hard for a knife to go that far up to a satellite, huh?
Yes, indeed. I believe that, once again, I believe that satellite will play a significant role to extend the reach for other technology means. Typically, 5G, it's complicated because it's a licensed spectrum frequencies. We're talking about fiber also that needs to accompany the development or the extension of 5G. So I see satellite to be playing a role in that. In such a case, what is network slicing? At the same time, you need to consider that network slicing is the next, large evolution of the operator, industry or the telecom industry as a whole. So network slicing is basically the stitching mechanism between resources and capabilities that belong to given domains. Now, with these domains, you will create what we call a network slice subnet. So each subnet from each domain will be stitched together to formalize what we call a network slice. So network slice can be extended in across different players, even companies that are collaborating together, but as well to be extended to these extended boundaries that we were talking about. It could be business, business footprint or operational footprint. Then in that case, you could extend, network slicing as you see fit. So if you imagine a 5G MNO that will be collaborating with the satellite virtual network operator, then in such a case, yes, they could collaborate to extend the notion of a slice, of an end-to-end slice, encompassing the domain one from the satellite network operators, embracing as well what the mobile network operator can provide to contribute to the slice notion. So this is where I see the evolution of collaboration and co-opetition, fundamentally fused together to formalize really new generation of services for end users or enterprise, of course.
Luc-Yves, when you mentioned the term 5G, you kind of teed up my final question for you. So what impact do you believe 5G will have on satellite networks in the future?
Well, fundamentally, I believe that there are a number of use cases that 5G will only be able to provide with the collaboration from satellite network operators. Typically, the MMTC approach. So the MMTC use case is actually associated with network slicing, and the goal is to have something that could be addressing the need for IoT devices that could be fundamentally, leveraged through, technologies that will be associated with satellite. And typically this is the notion where you can question the capability of 5G to address, rural areas and place where you have low density of population in these areas. And this is where, satellite could play a significant role. But as well for oil and for oil and gas, you could imagine a platform that is in the middle of the ocean. And obviously 5G is not capable of doing anything for them. So you can easily place and imagine satellite being the last mile technology that could be leveraged in these locations. But at the same time, Industry 4.0, you see a lot of industry players in different industry like manufacturing and everything. You can see these companies investing into plants that will be located in the middle of a state in the US or in Eastern Europe or somewhere in India where you don't have any fiber penetration. So obviously this is where you see satellite playing a significant role over there to basically extending the backhaul possibilities for 5G for one, but also to leverage fundamentally satellite as a non-terrestrial networks extension of 5G services.
Well, great. Luc-Yves, I think you've given our listeners a deeper understanding of the concepts around enabling dynamic satellite ground networks. Thank you very much for your time.
Thank you very much indeed for having me.
I'd like to thank our guest, Luc-Yves Pagal Vinette, Product Marketing Director for 5G Service Orchestration, Network Slicing, and Service Assurance at Amdocs.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.